Hello everyone, I'm Cong Li from Intel. Today I will give a talk on CPI for runtime performance measurement, the good, the bad, and the ugly. This is the joint work with Li Yi from Intel and Jianmei Guo from Alibaba Cloud. In runtime cloud computing environments, a variety of workloads with varying workload intensities are collocated together. Performance measurement then becomes a difficult problem. Originally used in microarchitectural performance characterization, CPI or IPC is now emerging as a proxy for measurement in such an environment, since it is generally applicable across different workloads. For example, it is used to evaluate the performance change in Google's WS meter and to detect contentions in Google's CPI square. Here we re-examine the use of CPI using two representative workloads, memory cache D and spec JVB under different workload intensities. We involve different settings, contention, change relevant to microarchitectural performance, different frequency scaling settings. We examine the change in CPI versus that in tail latency under the same throughput. An alternative matrix, RCPI, is introduced, where cycles are counted with the fixed base frequency. In cases where performance gets impacted by contentions or by a system setting change impacting microarchitectural performance, CPI is more sensitive than RCPI in identifying the performance impact. However, when the performance degrades by disabling tuple boost or improves by fixing at a higher frequency, CPI does not agree with the performance change, but RCPI does. In the bad, when frequency is lower, a cycle becomes longer in time length. Then smaller number of core cycles are spent in memory access, resulting in better CPI with worse performance. In the good, when the microarchitectural performance is worse, the execution time is slightly longer, utilization is higher, and the frequency is also higher. Exaggerated by the BIOS, CPI is even worse. Finally, we see that CPI or RCPI changes when workload intensity is different. This is likely due to the different use of microarchitectural resources. Therefore, using CPI appropriately is challenging. We need to comprehend the CPI's bias towards low-frequency settings, leveraging the good but avoiding the bad. We need to consider the difference of CPI due to a different workload intensity, for example, by modeling CPI with respect to the workload intensity. Here is the end of my talk. Any questions or comments are welcome. Thank you.